A very warm welcome in the course of numerical methods. We are in the module of interpolation, and as stated above that we need some basic calculations and some prerequisites for entering into the interpolation concept. Already one lecture is provided to you regarding the difference operators, specifically forward difference operator, backward difference operator and shift operator, and also their interrelationships. Now in this lecture we will mainly emphasize on the construction of difference tables, and obviously we are also going to show how they are interrelated. But before that, we have to show, just for the requirement of the construction of the table, that the higher order difference operators in the context of forward one and the backward one. So let us start it. We have already gathered the idea of forward difference operator, and if we have the definition like this, f of x plus h minus fx. Now this is the calculation what I am going to show it to you. It is independently important for our concepts as well as it is going to be important for the construction of the table. What is that? That is initially the second order forward difference operator, that is we are denoting it as like this del square fx. So we can write it as del of del fx. So according to the definition, if we proceed, it will be f of x plus h minus fx, and after that if we distribute it, we can write it as del of f of x plus h minus del of fx. So after that, according to the definition, we can write it as f of x plus h, that is f of x plus 2h minus f of x plus h. Then for del fx, we can write it again from definition, f of x plus h minus 1 minus plus f of x. So simplifying it, we can write it as f of x plus 2h minus 2 into f of x plus h plus fx. So initially you please try to think about it, that if I have x and y, and where y is actually our fx, then it is x0, x1 and dot dot dot, and it is your fx0, fx1 and so on. So if you want to find out, suppose del 2 of f of x0, then here you need f of x0 plus 2h minus 2f of x0 plus h plus f of x0, and you got it here. X0 plus 2h means f of x2, x0 plus h, then minus 2 f of x1 plus f of x0, and you can see it that f of x0, f of x1, f of x2, everything is known to us, so we can get this result very easily. But I want to mention another aspect from here to you, that this line, instead of writing in this approach, we can write it as f of x2 minus f of x1 minus f of x1 minus f of x0. And in the next line, if you think about the definition of forward difference operator, and if you put x1 in this position, then it is del of f of x1 minus del of f of x0. So you can get del 2 fx0 as directly calculated from the table, or parallelly you can get del 2 fx0 calculated from the first order forward difference values of f, because if you have fx0 fx1 in this way, so in the next part when you are thinking about del of y, or you can write it as del of f of x, in this column you are going to get fx1 with del, fx0 with del, and so on, and from these values also you can calculate this one. So when we are establishing this information, it sometimes looks to us clumsy. To avoid this particular thing, we are now going to represent it in terms of a tabular form, so that it will be easier for us to understand the thing. Not only that, before going to this part, I just want to mention that if you look at the coefficients of this del 2 fx, you will get it 1, minus 2 and 1. My question is that please have some brainstorming session over here, that in case of del 3, del 4, can you find out the symmetry through which you can directly write their expressions? One symmetry is that for 2 it is 2h, h and only x. So for del 3 it will be x plus 3h, x plus 2h, x plus h and x. But what will be the coefficients, so that you can claim about their symmetry and you can write the answers directly. So now let us move for the forward difference table. Suppose I am going to take a table like this: 1, 3, 5 and 7, and the corresponding values are, suppose, 5, 10, 20 and 45. So in the next column, my target is to write del y. So if I actually write it as y is equal to fx, then I can also generalized manner, I can denote it as x0, x1, x2, x3, and this is my y0, y1, y2 and y3, and we know that del of fx is equal to f of x plus h minus fx. So del of f of x0 is equal to f of x0 plus h minus f of x0, that is f of x1 minus f of x0, and we can write it as y1 minus y0. So in this position, del y, if I want to write it here as del y0, that means I want to write the subtraction between them, and here I want to write del y1 and here I want to write del y2, and most importantly and interestingly, if I want to write del y3, then the symmetry tells us that if I want to write del y3, then the symmetry tells us that I need y4 minus y3, but unfortunately y4 is not there, so I can't find del y3 for this table. That means if we are having four informations are there, we are getting in the first order forward difference operator three of informations, and the symmetry will tell us that in the next case we are going to get del 2 y0 and del 2 y1, and in the next case we are going to get del 3 y0 and it is gone. So please take the structure of this table, that it will be in this form. First information, second information, gradually one by one the number of information will be decreased. Next, y0 will always be there in the context of forward difference table, so the diminishing case will be from the lowest part of the table. So if it is x3, corresponding functional value is y3, it will go to y2, y1, y0, and it will be finished. And also you can find out that up to which difference you can go for this particular calculation. So let us complete the calculation. So here we will get 10 minus 5, that is 5, which is equal to del y0. It is 20 minus 10, that is 10, which is nothing but del y1, and 45 minus 20, that is 25, which is nothing but del y2. And in this regard, everyone can think about it, or you can get the idea that it is nothing but actually y1 minus y0, it is nothing but y2 minus y1, and it is nothing but y3 minus y2. So according to the symmetry, you will write it, already we have done it in the previous calculation. So here if we want to find out del 2 fx0 is del fx1 minus del fx0. So in the next notational point of view, we can write it as del y1 minus del y0. So here it is nothing but del y1 minus del y0. Del y1 is known to us, del y0 is known to us, and it will be also del y2 minus del y1, it is y. Del y2 minus del y1, and obviously then it will be del 2 y1 minus del 2 y0. Now we have to fill the data according to the given information, and for that look at this, it will be our column for del 2y and it will be our column for del 3y, and here del y1 minus del y0, that is 10 minus 5, we are going to get it as 5, and it is 25 minus 10, that means here we are going to get as 15, and here it is 15 minus 5, that is we are going to get it as 10. So every value we can calculate except this particular long calculation, because now we are going to just show you one thing, that del 2 fx0 actually we can write it as del 2 y0 is equal to y2 minus 2y1 plus y0. So Here y2 is 20, 10 and 5. So here we can write it as 20 minus 2 into 10 plus 5, that is 5, and what we got it here as 5. So we can get it here as 5. So we can get the value of 5 by using this first column corresponding to the values of y, but it will be rigorous. And instead of that, if we are going to use the second definition, what we have just managed it by different calculation, it will be always easier for us to apply it in our problems. Okay, this is your forward difference table. Now, according to the another structure of difference, that is called backward difference, we can make a study over here that if we are talking about backward difference here, then backward difference of y, obviously I can't use y0 because it will give us y0 minus y minus 1. Y minus 1 is not there. Y1, it will give us y1 minus y0. You can think about how. Already it is discussed in the previous class. If you can recall, backward del of fx is equal to f of x minus f of x minus h. So if you put x equal to x1 over here, it will be del of y1 is equal to f of x1, that is y1, minus f of x1 minus h, that is y0. So from the expressions point of view, y1 minus y0 and y1 minus y0, their expressions are same, so the value they will provide will also be same. But the notation from forward difference point of view, it is forward difference operator of fx0, that means it is nothing but del y0. But the same expression, same value, same thing, if we want to denote it from the backward difference operator's point of view, then just the notation will be changed and it will be backward difference operator y1. So what will be this backward difference operator y2? What will be this backward difference operator y3? So two things are important. First one, it is also diminishing by 1, but look at this, here the diminishing index is not the last one, it is the first one according to the definition, because y0 is there but there is no backward difference operator on y0. It starts from y1, y2, y3. So in the context, if I go for the second order backward difference operator, the same expression will come, but the notation will be changed and notation will be backward difference operator of order 2. It will be obviously y2 and it will be now y3. And in final case, for this particular table, if I go for the third order backward difference operator, the expression and the value both will be same, just the notation will be different. It will be del 3 nabla 3 y3. So we can see that in the forward difference table and in the backward difference table, basically both of them are same table if you are thinking about the expressions and the informations. But as their notations are different and as they are going to be used in two different interpolation formula. So both of them are very important, and both of them will be used in one by one. In one first one, Newton's forward difference operator or forward difference interpolation formula, and in the second case, Newton's backward interpolation formula. But again, I am trying to emphasize on this fact that both of them are very important, and you have not to make any confusion regarding the operators, symbols, and index. So, I'm not going to extend this one anymore. I think it will be very much helpful for you if you go through these references and also construct these tables if possible, because you have to emphasize on whether they are equispaced data or not, and also please try to identify the interrelationship between them as we have discussed now. Thank you all. Happy listening, happy learning.